So I'm working on number 3 of your homework problems in section 2.6, and we are told that the price P in dollars and the quantity X sold of a certain product obey the demand equation, and that X is equal to negative 6P plus 180, with P being between 0 and 30, including 30. Now, the first thing that we're asked to do is to express revenue, or R, as a function of P. So we need to recall from problem number 2 and from the notes that we took on this section that R, or revenue, is equal to the number of products produced times the price of each product. So when we are finding a function in terms of P, we're looking for I get my pen to write here, R of P will be equal to, and we know from our problem that X is, I'm going to use the sample that I did, which was a different problem. X was equal to, so let me put this up here, what my problem was. X equaled negative 3P plus 90. So then when I build my function, which I'm going to use as my model for this, I have R of P is equal to, remember now, X times P, and we know what X is. So we have negative 3P plus 90, and that whole thing is multiplied times P for the price. So now, to simplify this, we're going to use our distributive property, and we will multiply P times negative 3P, which gives me negative 3P squared, and then P times plus 90 gives me plus 90P. So that's the function of my model. So that is R of P equal to negative 3P squared plus 90P. And we would expect to have a quadratic in this section, since that's what we've been studying. We also would expect for it to be a quadratic that's opening down, which means we're going to have a maximum point, because this section is talking about maximizing the revenue, maximizing how much money I'm going to make on this process. So that was the part A of this question. Part B wanted to know what would be the revenue if the price was $26. So let's just label this as part A. Part B, so that means P is equal to 26. P equals 26. So since we're doing R of P, you've got to think of this in terms of R of X. And we use X as our variable. Same thing here, except that the variable on the x-axis will actually be a P. It'll be the p-axis. So then we are looking for the value of, we're going to evaluate our function at P equals 26. That gives me negative 3 times 26 squared plus 90 times 26. When you calculate that, you'll find that when the price is $26 for each item, the revenue for everything sold will be $312. Total amount of revenue at that price. Now, in part C, we are asked for the price that maximizes R of P. And before we do that part, I want to go to another slide. And what we're looking at here is a little screenshot of the Desmos, where I put in this function that I had. Keep going to Desmos and looking at these things. Blow them up, shrink them down, see what you need to find. But anytime that you are being asked to maximize a value, to maximize a function, you're going to be looking at a maximum value, an absolute maximum. So when we're looking at a parabola that opens down, we know that that maximum value is our vertex. And I'm trying to use the mouse there, and I need to be using the bamboo pad. So the vertex on this function that I have is the point 15, and with the y value, or an r of p value of 675. So let's just label these. So this is p, just like it would be x. So our x-axis is now p-axis. This quantity is r of p. So this is saying I have a maximum at p equals 15, and the maximum value for this function is 675. So now to go back to our previous slide. So in part C, we wanted to know what price maximizes this function, maximizes the revenue of this situation, of our story here. So what price we are looking for? If this was r of x, we would be looking for x. Since this is, let me hop back over here again. So if you think about how these axes are labeled, instead of x, this is p, and instead of r of x, this is r of p. So keep that in mind when you're maximizing in all these story problems, that the axes have different names, but that vertex works exactly the same. So that vertex is p and r of p. We go back over here and we're looking for the price. We are looking for, let's put in what our vertex is, since we can't see both screens at once. So our vertex, and I just found that using Desmos. You could have also have used the negative b over 2a to have found your p value, and then substituted that in and found the r of p value. But our vertex is 15,675, the ordered pair. So when we are asked to find the maximum price, the price that will give us, let me say that differently, the price that will give us maximum revenue. So I'm going to write that out. So $15 is the price that will produce max revenue. And I kind of ran out of, there is an E on there. Then part D, we're still working with our vertex, because in part D, we are asked, what is that maximum revenue? Well, that is the maximum value for this function. So our maximum value, $675, is the maximum revenue for this function. So why this is important, if you have a business and you have to make payments on your business, you have other expenses that you need to meet each month, you have to be aware of your pricing and how it relates to your revenue. If this function models your revenue, then if you have, no matter what your price is, If you charge $15 for each item, that is the most revenue you will get out of the situation that is defined by this function. So if you have other questions, please send me an email. We'll be meeting online beginning Monday, March 23rd. Until then, I'm just going to be sending out videos as people ask questions. So have a great day. Everybody stay healthy.